Hi friends, in this video we will talk about how to scale an application from one user to the 1 million user, because it's really very much important for the system design, because the scalability of an users from one user to the 1 million user, it doesn't happen in a single step. It will be takes a several steps, so that we can clearly discuss about each step, how the application will be evolve to scale from one user to the 1 million users. Okay, so now we will discuss about the first step. Now we will discuss about the step 1. So application will evolve from one user to the 1 million users does not happen in a single step. Okay, it takes several steps. The first, we will discuss about application with one user. That means application deployed in your personal laptop. Okay, start with the application deployed in your own personal laptop with single user. So whatever the components present, let's see. Okay, if you design a website, okay, if you design the website, this is a website you have designed, and you have take the domain name, that is called the DNS, and entire application will be deployed in a single server, that is your laptop. Okay, your front-end components, your controller components, and all your APIs will be present in the single server. In your database is also deployed in the single server. Okay, if the user will be contact through the website, it will be first step, it will be reaches to the DNS. Okay, from the DNS you have get the IP addresses. From the DNS it will be get the IP address. For example, if you give the www.chinmay.com, it will be get that the particular IP address. That particular IP address, later the request will goes to this particular server, and it will contact the front end part, because generally the front end part of an initially, if you stack is like, if you developed an Java application, in your system, generally the basic starting stage is front end will be the JSP and back end will be the Java. Okay, and Java is a .jsp files, and it will be talked to with the Java controllers. The controllers will be talk within database. This is generally the single application will have. Okay, when the request comes to the server, what happened when the request comes to the server, it will be contact the front end like the JSP part. From the JSP part, the request will be routed to the Java controllers. From the Java controllers, it will be routed to the database, and the later what will happen, from the database we will get forward back. From the database it will be coming to the Java controllers. From the Java controllers it will be come to the JSP. From the JSP directly it will be seen onto the screen. It will be rendered in our browser. That is a flow. Okay, for one user part. For example, if your application will be contacted through the mobile, what happens from the mobile applications, we can directly contact the APIs. We have developed the APIs, that is called that, instead of in Java controllers we have the REST controllers. Okay, instead of the Java controllers we have the REST controllers. I have taken the example as a Java application so that the most of the familiar about the Java applications like the Spring applications or whatever it may be. So that's why I take an example as a Java applications. So whatever the framework or whatever the language which will be, the flow will be the same. Okay, for example, from the mobile point of view, it will be hit the APIs will be hit the database, and database to again APIs, it will be request will be routed. In this way, all the components in the initial stage when the application will be developed for the single user, all the components, all the front-end components or back-end controllers and back-end APIs and back-end database will be deployed in the single server. Okay, that is the objective here. For one user there is no use of maintaining the multiple servers, right? So when you start your application with a single user, all the components will be deployed in the single server. That is stage 1. The later, what happened if the users will be the increases, then what we are going to make is, when the users from one user base, you have increased it to 20 to 50 users, for example. Okay, the step 2 what we need to separate is, we need to separate database, okay, from database separation into the separate server. Okay, so now what will happen, your application, for example, if you take an application, the front-end components, back-end components will be reside in one server. Okay, will be reside in one server, and your database component is reside in another server. This back-end components will be talked to the database. Okay, when the users got increased, what we made is simply we have to separate the database here. Okay, so now what happened, now if the website, the request will be the comes, the front end to the controllers were talked to the database, both the writes and the reads will be happen. In the similar way, from the mobile point of view, what will be happen from the mobile point of view, it will be talked to the APIs will talk to the database, both the writes and reads will be happen. Okay, now we will talk about the databases, which database we have to maintain. Before we need to understand about the databases, we need to understand the types of the database. Generally, database is of two types. Okay, two types. One is MySQL, not MySQL, SQL databases. Okay, and second one is NoSQL. Okay, what is the differences between the SQL database and NoSQL database? That's we need to understand the things. Okay, that one we need to understand the NoSQL from the SQL database to the NoSQL databases. What is the difference? First difference is first category of the difference is data model. Okay, the generally MySQL databases are relational databases. MySQL databases are relational databases. Relational databases. At the same time, the schema will be the standard schema. That means standard schema. That means we have to know the schema before. That means in the relational database we have to store the structured data. Structured data we usually stored in the MySQL databases. Okay, and it is also it maintains like rows and columns. Rows and columns. Data will be stored in the rows and columns, and it is also supports the joins. the relationships database, no, that if there are two tables, if you make the join query, that means we have to make the query at the same time. You have to fetch the database from the two tables at the same time using the joins. This joins concept will be supported in the MySQL kind of databases. At the same time, it is also support the ACID principles. So I made already the brief video on the ACID principles. Can you go through it? Okay, it will resolve all your doubts. Okay, atomicity, the consistency, idempotency, and everything, all this, and durability, all these properties was discussed in the detail. I already made in the video. You can go through it. Okay, this ACID properties is also supported by the MySQL databases. When coming to the NoSQL databases, there are many types in the NoSQL databases. Okay, in the NoSQL databases, we generally stored unstructured data. When we select the NoSQL database, when we select this like SQL databases, the generally SQL databases are used to maintain the structured data, whereas a NoSQL database is used to maintain the unstructured data. Okay, unstructured data. At the same time, if the amount of data is huge, like huge, there's some terabytes of data you need to maintain, you can go through the NoSQL database. Okay, there are many advantages of using the NoSQL database to maintain a huge amount of data. In further videos, we will discuss in detail about what is a SQL database and NoSQL database. For now, just I'm giving the idea. Okay, and we have to, if you use a huge data storage, we should opt the NoSQL databases. Okay, and it is consists of a flexible schema. It is not a fixed schema. It consists of a flexible schema. Okay, because it can store any kind of data. Okay, there are many types in the NoSQL databases. Okay, there are many types in the NoSQL database. I will discuss types here, not in detail, just in normal way. I will make another video to discuss about in detail. Okay, currently in this video we will focus about how to scale application from 1 user to the 1 million user. Okay, but I'm giving an idea about when to choose an SQL, when to choose a NoSQL. NoSQL types is here columnar database. That means it consists of rows and columns. Okay, data will be stored in the rows and columns. That is one type. Okay, and second thing is graph database. Graph database, data will be stored in the like nodes and edges kind of thing. Okay, at the same time, spatial database. Spatial data means like coordinates, like maps and everything. Okay, long latitude and longitude, everything. That kind of database is stored in the spatial database. At the same time, object oriented database. Object oriented database. Data will be stored in terms of objects. Okay, and another kind of database, NoSQL database, is document database. Document database, we use it to store the documents. Another kind of the database is like key value database. Key value database. Key value database, generally key value database is used for the caching purpose. It is also comes under the NoSQL database. Okay, and another thing is like time series database. Time series database generally used to store the graph data. Like not graph data. Graph data means like key value, like timestamp and value. Okay, for example, if you take an example for the time series database is like Prometheus, Cortex, and all these things are a time series database. If you observe, if you know an idea about the Grafana and all these things, the time series database was comes into the picture. For example, if you monitor the application, so what will happen that generally when we monitor the application, the every minute or every hour the data will be sent. Okay, for this hour the CPU value is like this, for this hour the memory value is like this. Okay, for this all the metric data, time series data means database is nothing but the metric data, the entire metrics will be stored in the time series database. Okay, if you have an idea on the Spring Activator, what the Spring Activator will generally do, the Spring Activator will collect the application metrics, right, a certain period of time, and it will be pushed to the Prometheus. Like Prometheus is a time series database. Okay, time series database. These whatever we discussed from 4 to 10 points, these are the types of an NoSQL database. Okay, in the NoSQL is also we have supported the rows and columns, like Cassandra and all these databases will come support the rows and columns only. Okay, rows and columns, but it will be stored and it can store an unstructured data. Okay, that is a difference compared to the SQL and NoSQL. It will be support to store the huge data and unstructured data. And graph database, for example GraphDB is a one of the example, Neo4j and all these comes under databases, comes under the graph NoSQL type. Okay, you can maintain the relationships. Okay, the spatial database is comes like it will use it to store the coordinates. Okay, and object oriented database is used to store the objects. Document database like MongoDB and all these comes under the document database. Data will be stored under the documents. And also another kind of document database is Amazon S3, Ceph and all these things also comes under the document database. You have to store the files directly. Okay, the key value database is comes under the Redis, Memcache, all these kinds are the example for the key value database. The key value database is generally used as alternative for the MySQL database, because the MySQL database, the generally we have data will be stored in different kinds of tables and having a relationships. To maintain the one query, to make a one query to get the data from combination of these two tables, we have to maintain the joins, right? So to execute the joins every time it will be taking more time. So once we need to execute the join from the SQL and it will be stored in the like key value database. For next time the request will becomes, it will be directly fetched from the key value. Okay, later the further stages we will discuss about the key value store in this video only. Okay, and the time series database is like we had to maintain the metric data, like the Spring Activator collected the metrics. So those metrics, those kind of metrics we have to store in the Prometheus. It is an example. This is the idea about databases. Okay, SQL database and NoSQL databases. Based upon the user's content, based upon your application type, you can choose a SQL database or NoSQL database. Based upon the user's unstructured data, you can choose a what kind of type of NoSQL database you can choose. Okay, it is completely depends upon the application type. Okay, for example, if this is a second stage, if the users basis increases from one user to multiple users, like so from 20 to 50 users, the second stage is you have to separate the database entity. Okay, that is the second stage. And third stage is if the user requests. Third stage is if user database, sorry, user of an application, users of an application increases from thousands, from hundreds to thousands, then we have to consider the stage 3 architecture. For example, until now what will happen, the main application will deployed in single server. Okay, in this front end, okay, and back end is there. Okay, front end and back ends there, it will be talk to the database. If the users will be the increases from hundreds to thousands, what will be happen if there is a single server, right? If a server will be the gone, what happened? Your server is gone. What happened? Automatically entire application is gone. Entire application is crash. Entire application is going to be crashed. Okay, to scale the users from hundreds to the thousands, you should maintain the applications. You need to increase the replicas, or we need to increase the capacities. Let's discuss those things in detail first. Okay, for example, you consider the server. Initially your user base is in hundreds, like you have to consider 4 GB RAM, okay, and 10 GB disk. Okay, entire applications, like all these components, like it consists of an front end, it consists of an back end, components are deployed. Okay, if user base is increases, what will be happen? You need to scale your application into two types. Okay, into two types generally. One is horizontal scaling. Second one is vertical scaling. Okay, the first one is an horizontal scaling and second one is a vertical scaling. Either we need to do the horizontal scaling, whether you need to do the vertical scaling. Okay, see, first understand what is meant by the vertical scaling. Vertical scaling means already we have the capacity of 4 GB RAM and 10 GB disk. Okay, what does a vertical scale means? If you increase RAM from 4 GB to 8 GB, if you increase a disk from 10 GB to 20 GB, this is called the vertical scaling. That means we are maintaining only the one server. Okay, what you do is you increase the capacity of that server. It denotes you made an vertical scaling. Then what is meant by the horizontal scaling? For example, we have already had one server, okay, which is of 4 GB RAM and 10 GB disk, and you didn't increase the capacity. Simply you increase the replicas of that server. Okay, instead of 1 you maintain the 3. Okay, 4 10 4 10. Okay, instead of one server your application will be run in the 3 servers. This is called horizontal scaling. Okay, because to survive the user traffic. Generally in industry, what will be the prefer? Horizontal scaling or vertical scaling? Industry prefers the horizontal scaling, because you made the vertical scaling, the users will be the increases. You increase the capacities. There is one drawback here. Drawback is, even you increase the capacities, you had the single point of failure. If the server will be the crash at any time, if user base is suddenly increases. Okay, if user base is suddenly increases, it is very difficult to increase the capacities at the moment. Okay, and increasing the capacities is also the costly as well. Okay, for example, if you consider an e-commerce website, you build an e-commerce app. Generally in the normal days, e-commerce app traffic is low, right? So you can survive with 4 GB RAM and 10 GB disk. Suddenly any festival moment is there. Okay, you are expected to be get the more users to your e-commerce platform. Before only you raise it to the 8 GB to 20 GB, you already made an vertical scaling. Okay, what happened? You expect the users, initially you have 10 users for your application, for example 100 users. You expected user will be increases in the festive mode to 2000, so you double the increases. What happened if the users will come as 3000 or 10,000 users will be comes to your platform suddenly, which is the beyond your expectation. Okay, at that time what will be happen? Your capacities was breached and your application, your server is got down. Once server is got down, your application is completely down to the users. Okay, because you don't know when the traffic will be the increases, right? Even for every hour it got changed, right? Even the festive time. So at that time, if you increasing the capacities and decreasing the capacities is a difficult process. If you consider the horizontal scaling, the what will happen? We have the 3 servers. The suddenly if the traffic is increases, okay, if you put an auto scale and if you use the Kubernetes and if you put the auto scale based upon the traffic itself, the Kubernetes will increases the replicas. Okay, the users based upon that user will be the increases replicas with same capacities, then your application won't down. Okay, so industry prefers the horizontal scaling. That is one point. And second consideration is, if you made an horizontal scaling, your application should be the stateless application. That is a one point we need to discuss. Your application should be the stateless application. Stateless application. That is a one point you need to make. Okay, why it becomes application should be the stateless application, we will discuss here clearly. Why the application will be the stateless application. Before discuss about the stateless application, we need to understand what is meant by the stateless application, what is meant by the stateful application, so that you can clearly understand why we need the stateless application for the horizontal scaling. Stateful application means if you had the session data, okay, session data means if a user got login, then automatically user got allocated to the one session ID. Okay, this session ID, for example session data, is stored in the application. Your stored in the server, on that particular server. Your application is designed in that such a way in that particular server, then it will be the stateful application. That means not only the session data, any cache data, any session data, or whatever the data. For example, your application data, simple difference is your application data is stored on your server RAM. Okay, your server RAM, that application is called the stateful application. If your application is designed, any kind of data, it will be the session data, or whether it will be any kind of an object data, will be stored in your server RAM, and you are accessing that for any kind of purpose, then it will be the stateful application. The stateless application is your application won't store any kind of data in the server RAM. Okay, your application won't store any kind of data in the server RAM. That application is called the stateless application. Just imagine here, we are maintaining the horizontal scaling. Okay, we are maintaining the horizontal scaling. Okay, if one user will be logged in initially to this server, okay, maybe the request, if session ID is created in the user, your application will be designed that if a session data will be stored in this server, if user made any kind of the request to the application, the next time the same user will be request, there is no guarantee that every time the request will be comes to same server. Okay, for example, you designed the application every time one user request will be goes to the same server. Okay, it is a server A, it is a server B. You design that user one application will always comes to same server. You made an horizontal scaling. User one is logged in. Suddenly this node is down. Okay, this node is down. Now what happened? User one session data is entirely gone, right? Because you are maintained in the server RAM. Okay, so once it will be crashed, what happened? The user one got logged off automatically. Okay, so that's why the horizontal scaling doesn't support. Your application will be supposed to design to store any kind of the data in the server RAM. Okay, so your application always should be the stateless. Another thing is, to support the horizontal scaling, one of the most important component you need to know is load balancer. This is a most important you need to understand to support the horizontal scaling. The load balancer is the most important. Let's discuss about the load balancer. This load balancer topic is very vast topic, but glimpse only I am giving here. Okay, what like databases, how I discussed about SQL database and NoSQL database, we will discuss about the load balancer here. Okay, load balancer. First we will discuss about the load balancer. What the load balancer will do. For example, we have 3 replicas, right? 1, you horizontally scaled the application. 2, 3. Okay, this is called server 1, this is called server 2, this is called server 3. 3 servers we have. Okay, this is an user. If user sends the request, which server is going to receive? Okay, your application is deployed in the 3 servers. Okay, for example, user 1 request is there. User 1 sends a request. Which server will receive? Which server it should go? Someone should be there in the middle. It should route the request, right? That's what the load balancer generally do. This is a load balancer which is sits in front of your servers and your user. Okay, now let's see what the load balancer will do. What the load balancer will helps for the horizontal scaling. The first one is traffic distribution. Already we discussed it, right? When the user gives the request from the multiple users, the multiple requests will come. The load balancer will distribute the request to servers. Okay, that is the first thing. And second thing is availability. Okay, load balancer will always have the information which node is alive. For example, this server is down. Okay, this server is down completely. This server is down. Now the load balancer will automatically grasp that this server is down. It will route the request only to these servers, only to server 2 and server 3. Okay, this is, it shows then your application cause high availability. It doesn't cause any disturbance to your application. And third one is scalability. Okay, as we discussed, when the load balancer is there, we can increase n number of replicas. Okay, with the same capacity. The suddenly user got increased, your replicas will be increased automatically. Okay, and your traffic will be routed to the load balancer. When the server got down, the load balancer will automatically detect and it will be send the request to healthy servers. Meanwhile, we can increase the capacity. If you use the Kubernetes and if you add the auto skill feature, what happened? The Kubernetes itself, when the server got down, itself automatically scale the new servers. Okay, based upon the rules we configured. Okay, in that way it will be increased the scalability. So when the scalability got increased, what happened? Performance is also the increased. Okay, because the load balancer will be the taking care of distribution of the requests as well. Okay, because so that one server, there is no chances that one server will get overwhelmed and other servers will be the free. Okay, the request will be evenly distributed. Okay, we had the algorithms in the load balancer. In the glimpse way we will discuss now. So based upon the algorithm, we will configure based upon your application type, it will be route the requests. In this such a way, the performance is also the increases. Okay, at the same time, it will be, we already discussed that the fault tolerance. Fault tolerance means what happened? Even the one of the replicas will be go down, your application will be usually serves the requests because we have the horizontal scaling in place. Okay, and also it also made the health checks. We already discussed it, right? The traffic distribution will be happen to the healthy servers. How it will be? Because the load balancer will always monitor the server's health. It also monitor the make the health checks as well. These are the things the load balancer will do. Okay, then how the request will be the routed? It has the algorithms. The algorithms of the load balancer is, first one is round robin algorithm. Second one is least connection. Third one is weighted round robin. Okay, fourth one is IP hash. These are the algorithms that generally the load balancer will have. What the round robin would do? What the round robin algorithm would do is it distributes requests equally. Okay, request will be it distributes the request equally. What the least connection will do? Least connection will do is it distributes request to the low active connections. Okay, for example, this server 2 has low active connections, then automatically the request will be distributed to the low active connected servers. Okay, and third one is a wait round robin. For example, one server is configured with CPU RAM is 4 GB and disk is 10 GB, and one replica is configured with this is 6 GB, this replica is 15 GB. What the weighted round robin algorithm will do is it distribute the requests to the highly capacitated replica. It will be distributed the request to the server 3 because it is having the high capacity replica. Okay, and fourth one is IP hash. I will already said that, like, if you build the mechanism that the user one always routed to the same server, is how this will happen is IP hash. Okay, for example, if the user one had IP address of 10.9.1.2 and the user 2 has an IP address of 10.11.1.3. okay, it will hash the IP address. It will always comes the one hash ID, right? One hash ID, it will be routed to the same server. That means every user always routed to the same server. If our application has that kind of dependency, if you use the IP hash algorithm. If you needed that your request will be routed to the most highly equipped resources replica, your load balancer will be configured with weighted round robin. For example, if you need the request will be routed to the which replica had an less active connections, then your load balancer will be configured with least connection. For example, if the request will be distributed equally to all the servers, okay, then your load balancer will be routed to the round robin. Generally, industry uses the round robin algorithm, most often applications. Okay, so now in the third stage, what we need to do is we need to scale the application. The generally industry follows the horizontal scaling. To make an horizontal scaling, two components will be required. Your application should be designed as an stateless application. At the same time, you need to configure the load balancer in between. Okay, this is what the application will be look like now. Okay, we are maintaining the two replicas here, two replicas, and the load balancer we are maintaining, and we are maintaining the database as a separate component as usual. This is the stage 2 we already discussed, and this is the stage 3. Okay, so already it takes more time. Okay, already 3 stages we discussed. The further stages will be there to make the 1 million. Currently, if this kind of architecture will scale up to users thousands, when the users in the thousands, more than 1000, this architecture will scalable. Okay, so if the user will be increases in lakhs and crores, okay, lakhs and crores, then we need to, in the lakhs, then we need to make your architecture to be more scalable. We need to add more components. Okay, we need to add the cache components, we need to make the CDN components, and we need to add data. We need to make a database replication, and we need to make a database sharding, and we are maintaining 2 regions. Okay, we need to maintain 2 regions. That is the last. If your application is in 1 million users, we need to maintain your application in 2 regions completely. Okay, all the things we will be discussed in the further video. Okay, in the one video it becomes too long. In this video we will discuss about the 3 stages. The first stage is a single server, and second stage is a separation of database, and we will discuss about when to use NoSQL and SQL. And third stage is we need to scale the application. Okay, horizontal scaling. This is what three stages we discussed in this video. Okay, in further video we will discuss further. Okay, thanks.